So yesterday we discussed about Azure Active Directory, tenant, and subscription well in detail. We tried that practically as well. And then we understood these two concepts. That is why VNets are needed, public IP versus private IP. So we have to discuss CIDR notation, VNet, subnets, energy, troubleshoot. Okay. I think before that, let's try to understand a few basic concepts. Okay, so we'll try to understand maybe what is TCP IP, what is TCP, then maybe what is IP or IP address, then TCP, okay, what maybe port, okay, what is HTTP, what is maybe HTTPS, maybe what is RDP, maybe what is SSH. Okay, guys, let's just try to have this session interactive. Anybody knows what, I mean, these are the fundamental and basic concepts. So let's first get clear understanding about these concepts and then we'll understand networking, VNets, and we'll see that practical. Okay. So anybody, I mean, whatever you think, can you explain these concepts? Just whatever you have understanding. So again, TCP IP, TCP IP, port, what is HTTP, HTTPS, what is RDP, what is SSH? Anybody? Any of these concepts and why we have that concept?
I think I can explain. SSH is for secure socket transmission. I just know like for secure communication, we use SSH.
Okay, great. Others, anything about from this? See, ultimately, what we want to do is, let's say this is our VM1. Or local laptop, whatever you think. Let's say this is our VM2. Ultimately, what we want to do is, we want that this VM1 should be able to communicate or to reach to this VM2, right? So we want to establish communication, correct? Simple. Now, considering this scenario, what do you think? What is this TCP, IP address, port, HTTP? What is your understanding?
So these are nothing but the protocols, which are nothing but in order to establish the connection between two machines, they have to follow some rules while exchanging the information.
Correct.
So
Yes.
one of the type is like TCP and the other one is like HTTP, yes. So
UDP. Actually, it's TCP, and yeah, you are correct. There is something called UDP. Yeah.
yes.
Great. Good attempt. So it was Mohan, right?
Yes.
Others? So again, guys, I don't want to, I mean, give lecture and come back next week. So of course, next week, but then let's try to have this interactive session there. Yeah.
IP address is like every machine is having like one of the IP address which can so with the help of IP address we can communicate to that machine. So every
Perfect.
system is having IP
Perfect.
address.
So in simple words, if VM1 wants to communicate to VM2, it should know the address of VM2, right? So let's say you want to send some invitation to someone. You should know his address, right? Or otherwise, how you will send? So IP address it is assigned to this VM1. Based on this, only VM1 can communicate with VM2, right? So it's an address, or it's, yeah, I think it's self-explanatory. It's an address, right? Let's say 138.72 point, what I can say, 22 point, I can say 8. Yeah. Great. So you have clearly explained that VM1, VM2, they both will have IP address. Yes.
And port is like where exactly to that machine means where exactly we are communicating. Means inside that machine port, like we can say it is like something, one kind of the gate through which we are connecting to that machine.
Exactly. Yes. Yes. So let's say this is one house. This is another house. So IP address is, let's say, address. Again, please don't go by this just like that. I'm just trying to explain in simple understanding. So you don't have to by heart. Okay. So yeah. So let's say this maybe, for example, I stay in Pune, I stay in Wakad and all that. And so this might be address. So this is my some other address. So let's say Bangalore, maybe some pin code, right? So this was IP address. That is to find where exactly over the internet that machine is. And port is something, let's say you want to send an invitation, you want to send it through door, or you want to, hand over that invitation to that person from, let's say, this window or door. So yes, you can go and you can hand over to that person, you can hand over that invitation through door, or you can drop it from the ceiling as well, right? I mean, of course, we go through door only, but just try to understand. So address is to reach to that computer, but then port, to exact which port you have to go, whether you have to go through this port or through this port or through this port. So these are ports. And one port, it's, let's say, RDP, that is 3389. I think it's 3389. Okay. Or it can be HTTP, that is from one VM we can connect to another VM over either RDP or HTTP. I guess it's 80 or 8080, or let's say HTTPS, it's 443, or if it's a Linux machine, over SSH, so I guess it's port 22. So TCP IP is just a terminology. And out of this we have this part, that is IP. So IP means finding the address where you want to deliver those packets. So again, we are communicating means from this VM1 we are delivering some packets to this VM2. Clear? So from this IP is IP address, that is, it's just a part which deals with finding the location or address where you want to send the packets. Any doubts in this?
No.
So again, we want to communicate from VM2, VM1 to VM2. So just having IP address is not enough. We should know the port as well. Okay. Then
Yeah.
TCP, it's a protocol. UDP is also a protocol. Now, from VM1 to VM2, I want to send packets or I want to transmit some data, right? So either I can use TCP or I can use UDP. 99% we all use TCP. It's because it's reliable. Basically, in simple words, when we send packets or data from VM1 to VM2, it's that first it's converted into packets. So that's it, these are packets. And at VM2, these packets are received and they are rearranged. And the message is received in the same sequence in which we send. So it's reliable. Plus, TCP ensures that the complete message gets delivered. And UDP is opposite. UDP means it's fast. Of course, now if we ensure it's reliable, complete message gets delivered. So TCP is slow. UDP is unreliable, but then it's fast. So again, simple words, TCP and UDP, these are just protocol or some way we communicate from VM1 to VM2. So we have understood what is TCP IP, we have understood what is TCP, what is IP address, we have understood the port as well. Right? So HTTP is one port. See here, we are trying to connect from VM1 to VM2. Either we can connect over RDP, see this RDP port, or HTTP or HTTPS. So HTTP, HTTPS, RDP, these are ports. Any doubt, guys, in this? So guys, is it clear?
Yes.
Yes, Ashal, good.
Yeah, it's clear, very clear.
And I'm sure you, I mean, you might not have this type of simple knowledge before that. So there is, I mean, we can go in much detail as well. So there is something called OSI model. So there are level like level 1, level 4. So TCP works at level 4, HTTPS works as level 7 and all that. So there is absolutely no need for us to go in those details. And honestly, neither I know. So OSI and OSI level details, which layer works at what. So until and unless you are a pure networking guy, you should know it. Otherwise, if you are from developer background, testing background, this is more than enough for us. Okay.
SSH, which is located for accessing the Linux machines.
Correct. We'll see that. Yeah. So now our focus is, let's try to understand these four: HTTP, HTTPS, RDP, SSH. Okay. I'll just clear the concept. This board. Okay. So TCP, HTTP, HTTPS, RDP, and SSH. See guys, again, let's say this is public internet, that is our local laptop. Right? And let's say this is Azure Cloud. And let's say this is a VM in this cloud. Now, let's say to this VM, this is the public IP. So again, 138.72.8.8 maybe. Now, from this public internet, if I want to go into that machine, let's say I want to go into that machine and I want to install required software as if I'm working in some other machine next to me. So how we connect to this VM? What we do? Guys, have you tried something like this? So if I say
Yes, Arshal. So it is like using some client tools, we will be connecting to that.
RDP, that means, right? This, can you see this my screen? Remote desktop. So for example, here, if I enter that public IP of that VM, I can simply connect RDP or I can go into that machine. Clear? This is RDP. I guess you must have tried that.
Yes.
From your local machine, you connect, or from your local machine, if you want to connect to that some remote server, you go into that machine. You go RDP, correct?
Yes.
So RDP is one of the way to connect to machine. Similarly, if it's a Linux machine, to go and let's say you want to install something, you go and use SSH. Now, HTTP means, let's say if a website is hosted in this machine. So for .NET guys, we can install something called IIS. For Java guys, I can install something called Tomcat. That means in IIS, we can host a website. In Tomcat, we can host a website. So ultimately, when we access this website, which is hosted in this VM, that means indirectly from our public internet, that is from our local laptop, we are connecting to this VM over HTTP or HTTPS. Any doubt? So again, from public internet, a way to connect to this VM is over HTTP or HTTPS. Clear?
Yes, Harshit.
Okay. And a little surprising thing, behind the scene, HTTP or HTTPS or RDP, they use TCP only. So again, TCP is a protocol. So these ports, when we connect to the remote machine over HTTP or HTTPS or RDP or SSH, behind the scene, they use TCP only. So TCP is a protocol. I guess this might have been a little surprising for you, right?
Yes.
In simple words, you can consider, let's say this is VM1, VM2. TCP is like a road and HTTP, HTTPS, RDP is like a car through which we travel from VM1 to VM2. Will it be easy to remember?
Yeah.
Clear? That's it. So if you know this, your basic concepts clear. Any doubt in this? Should we go ahead and let's try to understand now HTTP versus HTTPS?
Yes,
Yeah.
Harshal, all clear. Yes.
Just clear this numbers. Okay, now let's try to understand HTTP versus HTTP. Now tell me what is the difference? Whatever you know.
Security is
HTTP.
included in that HTTPS when I is connecting to the machine, other machines.
Okay, great. Someone else?
Yes, HTTPS is more secure. Because it uses some certificates.
Great, good. Now, next question. How exactly it works behind the scenes? Well, you can try. I mean, whatever you know. Okay. See, again,
So-
this is, yeah.
So whenever a request is sent using HTTP, the request will be sent to other machine in a plain text. Whereas if you use HTTPS, it will be securely sent to. I mean, like the communication between two systems will be happening very securely if you are using HTTPS. So whenever a hacker tries in between to access that request, if it is HTTPS, he will not be able to do that. Whereas if it is HTTP, he will be able to read that request data.
Correct.
It will
Absolutely.
be
Absolutely.
encrypted form.
Yes. So that means communication is secure. That means it's encrypted. Correct?
Yes.
If HTTP, it's not encrypted. Okay. Now, next question. How exactly this encrypted communication works? Okay, see. Now let's say we have this remote server. And let's say we have hosted a website in this web app, correct? And let's say this is our local uh, Okay, then let's do it. Let's say this is our public internet or local lab. Right now, if it's HTTP, that means let's say you are trying to access some banking website. So you go, you hit that home page, it gives you the home page, and you enter your username password. Correct? Let's say if it's HTTP, that means if there is a hacker, so let's say in between there is this hacker. He can see your password because it's, as someone said, it's a plain, non-encrypted. So obviously the worst solution, right? Correct?
Yes.
Now we go with something called private key, public key. So this server, it will have something called private key. And we have public key. So when we hit that banking website, it returns us that homepage, we enter the password. So again, all this happens behind the scene. We don't even, we are not even aware that this is all happening. So that our browser and that server takes care of that. Okay. So here we enter the password and it gets, encrypted using this public key. So our password is now encrypted using public key. Now, to decrypt or to see the password, anybody requires something called private key, and private key is always present on the server. It is never exposed. That's why it's private key, right? So to hacker, of course, he can see this encrypted password. But now, will he be able to actually see our password?
No.
Why?
Because that is encrypted and
The server.
To decrypt it, he needs private key, which he doesn't have. Right?
yeah.
Clear? I mean, again, this is the password which is encrypted using this public key. So public key, of course, anybody has. Hacker also has that. But what's the use of that? Because this password, it can be decrypted only using this private key, which server never shares with anybody. So do you think our solution is secure?
Yes.
Now, can you find one more potential issue with this? See, when this server for the first time is sending this public key to this public internet, that is to us, that public key, can't this hacker get that public key? So let's say this, I will say PUB K1. So hacker may get this public key and he may replace and he may change it public key 2. And he may give us public key 2. We are not even aware. We think that, okay, this public key 2 is something we got right from the server. But hacker, he got that public key 1, which is actual the public key, but then he changed it to this public key 2. And for this public key 2, he already has private key. Are you getting? See, original public key is this public key 1, and original private key is this private key 1. But he changed that public key which we are receiving from that server to this public key 2, and he gave us to that. So again, if we enter password, it will be encrypted using this public key 2, right? But then now this hacker, he already has that associated private key 2. So yes, he can decrypt it, right? Guys, are you understanding?
Yes.
Yes.
And that's why we have something called CA, Certificate Issuing Authority. We call it CA. So basically what happens is, when this public key from the server comes to us, we are not sure, or our browser is not sure whether it's been genuine public key or it's been changed by this hacker. So basically, there is something called certificate which is installed on this server. So our browser, it because we have that certificate installed on that server, our browser, again, this certificate, it is issued by something called certificate authority. So our browser, again, all this happens behind the scene. It goes to this certificate issuing authority and it verifies whether that public key which it received, it is actually the genuine public key or not. So yes, CA or certificate issuing authority tells yes, it's a genuine, and then our password now gets encrypted using that public key one, that is, which is the actual genuine public key, and now the communication happens. So all this is HTTPS, and hence on this server we have to install the certificate. So behind the scene, this concept works. Clear, guys?
Okay.
Yes.
Okay, guys. So this was about the basic concepts, and now, guys, we can move to this CIDR, VNET, Subnet, energy. Okay. So, guys, first, what is this CIDR notation? Anybody knows what is CIDR notation? Why we have that? Anybody has any idea? No, nobody.
Nope.
Nobody. Okay, why we have this CIDR notation? Okay, guys, please don't Google and chat GPT. Okay, just to answer question. Okay, see, we are saying that this is our Azure virtual network, our own VNet. This is our VM in this VNet, VM1, VM2. Okay, I guess before that, I think, no, let's just understand what is IP address actually. Sorry. IP address. So guys, can you tell me what can be, I mean, okay, so let's say this is my IP address sample 138.72.22.22. Is this a valid IP address?
Yes, looks valid.
It's a valid. If I say 138.256.22.22, is this valid? Is this a valid IP address?
Yes.
If I say 138.3 30 let's say 384.22.22, is this valid IP address?
No.
Not
No.
valid.
Hmm.
Is this IP address valid?
Yes.
Yes.
Yeah,
It's not.
it's between 0
Because
to 25.
it can be up to 255 only.
Oh.
So it can be 255 only. So each of this, this is 1 byte, this is 1 byte, this is 1 byte, this is 1. It can be 255 only. So this is not a valid IP address. Okay, now let's discuss this 138.72.22.22. Okay. Can I say this is 1 byte?
Yeah.
Can I say these are 8 bits?
Yes.
So that means in IP address total we have, can I say 4 bytes and 32 bits?
Yeah.
Correct?
Hmm.
Now, what will be the bit representation of this IP address? How you will find it? So just simply can say convert IP into binary, maybe. What was our IP address? 138.72.22. You can go to this. Okay, 138.72.22 maybe, and I will say convert IP to bits, that is binary, and this is its representation. Okay, so let me just write it. Okay, but then let's say this 22, how these 8 bits come to this 22? That's the question, right? Or how these 8 bits come to this 138, right? That's the question. So let's find the position of those 8 bits. Okay, so this 0 is 0's position. This, okay, let me, 0's position. This one is first position. This one is second position, third position, fourth position, fifth, sixth, and seventh. So that means, see this 0, it means 0. 2 raised to 1, it means 2 raised to 1 means 2. 2 raised to 2, it means 4. 2 raised to, sorry. See, this is 1, right? If it's 0, just take it 0. See again. If it's 0, assume it's 0. Sorry guys, I'm confusing. See, this is, see, we have these 8 bits. Again, I will start all over again. This 22, it means these 8 bits. And the position of these 8 bits is 0, 1, 2, 3, 4, 5, 6. Now, at 7th place, we have 0. So that means, let's assume it's a 0. At 6th place, we have 0. That means it's a 0. 5th place, we have 0. That means it's a 0. But at 4th place, we have this 1, right? So that means the value for this, it will be 2 raised to 4. That means it will be 8. Say 8. Again, at 3rd position, we have 0. So again 0. At 2nd position, we have 1, right? Sorry, this one. So that means it will become 2 raised to 2. So it's 4. At first position, again we have 1. That means it becomes 2 raised to 1. So it's 1. So sorry, 2 raised to 6, it will be 16. Okay, I think guys, I'm just confusing. Let me just explain it again. Just forget everything. Have you understood that this IP address got converted to this 8-bit? See guys, it's important. Only after that we will be able to understand CIDR notation. Okay, that's why we are covering. Have you understood that? And it's simple. I mean, I know probably I could not explain it better earlier, but it's really simple. And now I will explain it. But have you understood that how we simply converted this IP address in those bits? We simply
Yes.
used Google, right? Simple. But now our question is how exactly these 8 bits correspond to this 22, or how exactly these 8 bits correspond to this 138. Is that correct? Let's try all over again. So let me just take it this simple. First, let's find out the position of all those bits. So again, this is 0 bit, 0 position. This is first position. This bit, second position. This bit, third position. Fourth position. Fifth, this 0 is sixth position, and this 0 is seventh position. Clear? Any doubt?
Yeah, clear.
No doubt.
Now, where we have all zeros, just assume the value for that position, it will be 0. So here we have 0, it becomes 0. At 6 also we have 0, becomes 0. At 5th we have 0, it becomes 0. At this we have 1, so let's ignore that. At 3rd we have 0, so again it becomes 0. Here we have 1, let's ignore that. Here we have 1, ignore that. And at 0th we have 0. Correct, great. Now at first position we have 1, that means position is 1, right? So it will become 2 raised to 1. Again, here we have 1, position is 2, it will become 2 raised to 2. At fourth position we have 1, so it will become 2 raised to 4. So it becomes 2, 2 raised to 2 is 4, 2 raised to 4 is 16. It becomes 22. Now is it clear?
Yes.
Yes, Arshit.
Clear?
Yes.
So let's try one more. Let's try for 72, how it comes. So again, let's find the position. So it will be 0, this is 1, this is 2, 3, 4, 5, 6, 7. Again, 0, 1, 2, we have 0. So let's say 0, 0, 0. Let's ignore this one. 4 and 5 we have 0. So 0. And 7th also we have 0. The only thing we have is this 2 raised to 6, right? And we have this 3, that is 2 raised to 3. So 2 raised to 6, how much? कितना आता है? 32 plus 64. 2 raised to 3, 8. It becomes 72. So yes, we have 72. Clear?
Yes.
Yeah.
But confusing. Was it little confusing, right?
No, it's clear now.
So we proceed to understand CIDR.
Yes, I think you're clear with the concept.
Okay, anyway, you can refer that recording again. Okay, now. So what we have understood is ultimately this IP address, it becomes like this. And now if I say maximum highest possible number, it can be 1111, right? And
Yes.
you will find it becomes 255. That's why maximum number we can have 255. Clear?
Yeah.
Now, okay, we are saying this can be our virtual network. Great. We said that, okay, we have VM1, VM2. We say, now let's imagine there is no public IP to this VM, both VMs. Only it has private IP. Let's say the private IP of this VM is 10.0.0. Maybe I say 8. And private IP of this VM is 10.0.0. Maybe 10. So how we assign this private IP to this VM, or from where exactly this got this private IP? Can you guess? Any idea?
Can you come again?
How this VM got this private IP? Or, I mean, what is that thing behind the scene based on which these VMs got this private IP? I mean, it can be anything. It can be any private IP. But what is that thing which, I mean, based on what these VMs, they got some random private IP? That you won't be able to get. So there is something called VNet IP address range. So basically what you can do is you can say 10.0.0.0 up to 10.0.0.255. This can be my VNet IP address range. So that means both these IP addresses 10.0.0.8 and 10.0.0.10. Do they come in this sequence? So again, it will next IP address will be 10.0.0.0.1, 10.0.0.0.2 like that. So this is my IP address range for this VNet. So total, I have 256 IP addresses. See, 10.0.0, it's constant. The only variable part is 0 to 255, correct? So that means total I have got 256 IP addresses. And that is the range or one of the IP addresses, or from these two IP addresses, that is from this IP address range. Now, this IP address, is it from that range? And this IP address, is it from that range?
Yes.
Correct? See, 10.0.0 is constant part. So again, 0. And 0 to 255. So 8, yes, it's there in that range. 10 is there in that range. So whatever VNet IP address range we provide, based on that, our VMs get IP address. Clear?
Okay. Yeah.
Yes.
Any doubt? But then the next question is how we provide this, or how we specify this IP address range, or how to configure this range, right? That is the next question. For that, we have this CIDR notation. So using CIDR notation, when we are creating this VNet, we provide the range and we said, okay, great Azure, you are creating a VNet for me, but then for this VNet, please provide me total 256 IP addresses and this should be the range. Now, of course, we are not yet discussed CIDR, but are you clear what is CIDR and why we use CIDR?
So, Harshal, if we are providing this IP addresses like 0 to 255 within one particular VNet, we will be able to create around 256 VMs, right? I mean, like 255 VMs from 0 to 255. Is that correct?
I think we should be able to create not 255, I guess around 30-40. See,
Okay.
first thing, out of 256, I don't know that exact number. I guess nobody knows, but around 10 to 20 are used by Azure itself for its internal management. So these are reserved. Okay. Now, when you create VM, you create some other resources as well. So you may create something called storage account, storage or disk. So if I'm not wrong, probably to disk also private IP gets assigned or not. Let's assume it gets assigned. So in case if it gets assigned, so if we create a VM, that means to this VM we assign some disk, right?
Yeah.
This is hard disk, SSD or HHD.
Yes.
So let's assume to the disk as well, private IP gets assigned. So this VM it will have one IP, this disk will have one IP. Yeah. If it does not get assigned, then yeah, we may have more number of VMs we can accommodate. But I guess you understood the concept that each such
Yes.
resource in that VNet, it will have private IP. Clear?
Okay.
So technically, logically, yes, we can have 256 VMs. But then some are used for internal management, some. So for example, if I create something called private endpoint, so for that also one IP address will be assigned. So like that, yeah, there are quite a few IP addresses, private IP addresses, which get used and we may not be aware about that. Clear?
So mainly to create like a private IP address range, we are using CIDR, right? CIDR notation.
Exactly. That's the summary. Yes. Any doubt? And now the question is, what is CIDR and how to use it? So let's say, again, guys, generally we follow that. See, normally when we are creating private IP address range, we follow this convention only. Either this range, that is 10.0.0.2, like 10.0.0.255 or 20.0.01, 20.0.0.2, like that. So normally these naming conventions or this IP address range convention is followed when we are working with VNets. Okay, so please remember that. Now I'm creating a VNet and now I want to tell Azure that, hey Azure, give me total 256 IP addresses and the range, it should be so for this we will use CIDR notation and we will specify something this like this. So this 24/24, it means this is my IP address range, or it should start with this. And this 24, it means 256 IP addresses. Or let's say I want 65,000 IP addresses. So I will say, hey Azure, create VNet with this range /16. So it will become 65K IP addresses. But guys, the question is how this 24 corresponds to this 256 and how this 16 corresponds to this 65, right?
Yeah.
Correct? So for that, now we have to understand that bit representation. See, again, let's say 1, 2, 3, 4. Okay. One, two, three, 4, 5, 6, 7, 8. Great. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. First thing, larger this number, smaller is the range. So this thumb rule you have to remember. Larger this number, smaller is the range. And smaller this number, larger is the range. Is it clear?
Yes.
Now, this 24, it means ignore first 24 bits. So here we will ignore these 8 bits, these 8 bits, these 8 bits. And the only remaining part we have is these 8 bits. And for these 8 bits, what maximum we can have? From 0, 0, 0, 0, 0, 0, 0 to all 1, 1, 1. Is that correct? So first 24 bits we have ignored and we are saying it should start with 10, 0, 0. So that means these 10 bits, 10, 0, 0. And The only variable part is this last 8 bits because first 24 we have ignored. So the range it can be, this stands for 0 and this stands for 255. So it becomes 10,000 to 10,000 to 255. Is it clear?
Yes.
Similarly, if 16, that means ignore first these 16 bits. And then we have all the combinations from these remaining 16 bits. Correct? So it can be all zeros. I mean 16 zeros, okay? Up to all ones. So as you can guess, this permutation combination would be large number and it becomes 65K. I know you are not understood, so let's understood it in a new canvas. So again, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So again, we are discussing 100 point, sorry, 10.0.0.0/16, correct? And I said it becomes 65K, that is 65,000 IP addresses. So 16/16 means first ignore these first 16 bits. Okay, let's ignore that. So this part, that is 10.0, it will be constant. Clear?
Yes.
And let's assume this part now first. Okay, let's just forget this out. It becomes max, this part, it can be 0, 0, all zeros to all ones. So it becomes 0 to 255. Clear? So
Yes.
my IP address, it becomes 10.0, and for time being, let's imagine this 0. So this IP address range is becomes 0 or 10.0.0 to 1, like that, 10.0.0 to 55. So I got these 255 IP addresses. But again, here also we can have all zeros to all ones, right? Because the only first 16 bits we have ignored, right? So again, this range, it can also be from 0, 0, 0, 0, 0, 0 to all ones. Am I right? So the next, it starts with 10.0. Now 0 is complete. It may become 1. It may become 0 again. 10.0.0.1, 1. 10.0.1, 2, like that up to 255. Now next it becomes 10.0. Again, see, 10.0 is constant. The only variable part is this and this. Again, it becomes 10.0. Now 1 completed, 2 points here, it becomes 0. Now next it will be 2, it will be 1. Now next it will be 2, it will be 2. So like that, maximum range we can have is 10. Again, I will write over it. 10. This 0 is constant, right? Here I can have 255. Again, last one, it will start from 0 to 10.0, 255, 255. So essentially, I have the range from 10.0, 0, to 10.0. Again, only this is constant, but up to 255, 255. Now, is it clear?
Yes.
So again, simple. Larger this number, smaller is the range. If I say /8, it's even bigger. The only constant will be only 10. And for rest 3 bytes, that is 0, 0, we can have all the combinations. That is 0, 0, 0 to 255, 255, 255. Any doubt, guys, in this? थोड़ा confusing था क्या? Difficult to understand?
Yeah, it will work by all the combinations. Beyond 24, sometimes in the organization level, I can see /25, 20/26/27.
Yes. And that now I'm going to show you. Now, I think enough about concepts, but it was actually required. Okay. I think we have just covered CIDR only. Okay, let's try to cover VNet and Subnet. Okay, so if I go here and let's say here, maybe guess, let's say maybe portal login. Let's click on virtual networks. I will say create a one. So again, now you understood, right? I mean, understanding the concept was a difficult thing. Now it's really simple. So again, we are trying to now create a virtual network. So I will say create a virtual network. I'll say maybe VNet demo. Actually, I have done VNet demo. I'll say okay. And I will say maybe our VNet. I'm creating it in Australia East. Say next. Let's just ignore this as of now. We'll say next IP address. And obviously, if we are creating a virtual network, see again, in this virtual network only, I mean, when we create a VM and all that, so we can deploy our resources in this virtual network. So before that, when we are creating virtual network, we have to specify the range, and that is that CIDR name, CIDR range. And now, can you see this? What by default IP address range it says? By default, it says I can create it for you 10.00/16. See, it's 65K IP addresses. Clear? See again, larger this number, smaller is the range. So for example, here instead of 16, if I say maybe 28, you see, we are getting only 16 IP addresses. If I say maybe 8/8, see, we are getting huge number of IP addresses. Do you want me to show how this 28 comes to this 16 IP addresses, or you think you can find out? Again, first 28 bits you have to ignore. See, this 8, this 8, this 8, and this 4 bits you will ignore. Only variable part you have is this one. Correct? See, this 1, 1, 1, 1. This only variable part you have. So that means essentially you have the range of 4 zeros to 4 ones. And it becomes 0 to 15. That is total 16 IP addresses. See, all 0 means 0, all 1s means 2^1 plus 2^2 plus 2^3 plus 2^4. No, sorry, 2^0 is 0th position. This is first, this is second, this is third. 2^0, it becomes 1. 2^1, it becomes 2. 2^2, it becomes 4. 2^3, it becomes 8. So if we add all this, it becomes 50. And that's how we understood that convention. Okay, again, I guess. I mean, is it clear or you want me to explain again, guys?
No, it's
Okay,
clear.
let me just quickly explain it again. So again, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We are saying IP address range of 10.0.0.0/28. That means ignore first 28 bits. So ignore this 8, this 8, this 8. So only remaining we have is these 4. Even these 4 are ignored. So we have 4. And the max combination for this 4 bits is 0, 0, 0 to 1, 1, 1, 1. Now for this one, position is 0. For this one, position is 1. For this one, position is 2. For this one, position is 3. That means it becomes 2 raised to 0 means 1. 2 raised to 1 means 2. 2 raised to 2 means 4. 2 raised to 3 means 8. 8 plus 4 plus 2 plus 1, it becomes 50. And all these 4 zeros, this means 0. So combination we can have 0 to 50. So the next it will be 0, 0, 0, 1. Then 0, 0, 1, 0. So again now it becomes 1, it becomes 2. Up to 50. Now is it clear? And therefore we understood that how we can convert those bits in IP address. Guys, I think, am I not able to explain properly, or it's really difficult to understand? I can sense that.
Here in the last, you took that 4 digits, right? 4 means last 111. So you just take it as the 2 power 0, 2 power 1, 2 power 3, 2 power 4. So when we calculating it, we'll be getting the 15, totally 15.
Correct.
Yeah, I got that. So in the, this is the one example. For all the scenarios, we should we take that last that 4 combinations only for all the other IP addresses. I want to check.
For this range, yes.
We have to calculate this.
Let's say you are okay. I guess let me try to explain. 10, 0, 0, 0 slash, let's say 27. Let's take this example.
Okay.
So again, you will ignore first 27 bits. Clear? Only remaining bits you have is last these 5 bits. Oh, sorry, not this 5. These 5 bits. Yeah, the clear hai? Is it clear till this? That only remaining 1, 1, 1, 1. That is 5 bits. Is it clear?
Yes.
Okay. Now, for 5 bits, the lowest number we can get is all 0. Is that correct? And for these 5 bits, the highest number we can get is all 1s.
Yes.
Is that correct?
Yes.
The next number in this range, it can be 0, 0, 0, 0, 1. Correct? The next number, it will be 0, 0, 0, 1, 0. Then 0, 0, 0, 1, 1, like that.
Yes.
So if you find this, it comes 0, it comes 1, it comes 2, like that, it comes 31. So total we get 32 bits. So our IP address range, it will be 10, 0, 0.0, next 10, 0.0.1 up to 10, 0.0.31. That is total 32 IP addresses. Now it's clear?
First you took only last 4 digits, Harshal. Why again you took 5 digits, last 5 digits?
Just example. I just took an example. So example, if I show you, just for your understanding. So here if I say 28, let's take 27. See, it becomes 32 IP addresses.
Okay, so we have to minus 32 minus 27.
That means
so total is 32 minus 27. You will be getting 5.
5. So you have to get all 0, 1 combination for those 5 bits.
Okay, can you go to the Azure portal, Harshal?
Yeah, I go, but guys, have you understood this, or I think it should not be that difficult to understand.
Understood.
We understood, Harshal.
I can understand. Yeah, I can understand.
Okay. Yeah, Vinita, you said something. Yeah.
Means 32 minus 27 means we have to, means for example 26 means like how much minus value we will get, we have to consider that many digits, right, from last.
Yes, from 32. Yeah. So for example, I think he explained clearly. So example, if I say 26/26, so 32 minus 26, it becomes 6. So 6 zeros to 6 ones combination, whatever IP address we get, that will be our range.
But it
But let me
says
show you.
64.
Yeah, so that's correct. So 6 bits, it means 64. No? So again, larger this number, smaller is the range. So if I say 28, it becomes only 16 because this 28 is larger number. But let's say if I say 10, 10 is smaller number, right? See, this range becomes big.
Actually, even the cost associated with selecting these addresses will also vary, right? Depends upon the selection, right?
Actually, even I'm confused. It says that virtual network is free, but then we don't create virtual network just like that. Basically, we create something called private endpoint and all that, DNS zones. So for that, cost is associated. So technically, virtual network is free actually.
Okay.
Let me just
Fine.
chat GPT. Yeah, I think that's I mean, even I'm sort of, it's a good question that, but that I know that virtual network in a sense is free. Okay.
Okay.
But then obviously we use it for some purpose and there is a cost associated with that. Okay, now let's just assume that example of /28 only. Okay, so that we get only 16 IP addresses, or maybe I will say 24. So we get 256 IP addresses, right? And here now if I say review plus create, say again guys. Okay, I think we have not discussed subnets. Okay, let me first explain subnet.
If we create VN also, it will show in the resource group. Will that show that in the resource group?
Yes, it will. Yes.
Means anything we can see in the resource group, right?
Yes. Whatever you create in that resource group, that will be in resource. Okay. Now, as this was our, let's say, VNet. And I specified that IP address for this VNet, it will be 10.0.0/24. That means I got total 256 IP addresses, right? So again, those 256 IP address, they will be 10.0.0.0, 10.0.0.1, 10.0.0.2 up to 10.0.0.255. So total 256 IP addresses are got. Now, when we create a VNet, or let's say I want to create a VM in this VNet, we don't directly create a VM in this VNet. Rather, we have something called subnets. This will be one subnet, this will be another subnet. And now from this IP address range, that is from this total 256 IP addresses, I can assign a sub IP address range to this subnet. So for example, I may say for this subnet, I want to assign 10.0.0.0 up to, let's say, 10.0.0. Let's say 132. And for this, I may say 10.0.0.133 up to maybe 10.0.0.255. So that means total, I mean, of course, same IP address range we cannot assign to subnets, right? So again, this IP address range, it will be the part of our main VNet IP address range only. So again, you see, it starts from 10.0.0 to 255. So for subnet 1, I say 10.0.0.0 to 132 assigned to subnet 1. From 133 to 255 assigned to subnet 2. So it just was organization, better organization. So again, VM, if we have to create, we cannot create a VM directly in VNet, but we create in some subnet. And if I create a VM in this subnet, this VM, it will have IP address from one of this range. So it may be, let's say 10.0.0.6 maybe, or 10.0.0. maybe 88. That's it. That's the only thing we have subnet for. Clear?
So any resources we cannot create directly in VNet, right? So that should be in subnet only.
Yes.
Is it
If any resource, if we create in a VNet, yes, that will be in subnet only. But that's not necessary. Every resource will create in VNet only. So for example, VM, yes, we create in VNet. But for example, let's say app service, there is no need to have VNet for app service.
okay?
Okay, for app service, or let's say you want to create Azure function, there is no need to create a VNet. Absolutely,
Means,
VNet doesn't come.
yeah, for the resources which is having like IP addresses, those should be in that subnet only, right?
As of now, you can consider yes. As of now, yes.
Okay.
Clear?
Yes.
So guys, now if I go here, if I go to my Azure portal, I can say yes, /24. That means for this VNet, that is for this parent, give me total 256 IP addresses. Okay. And here we are creating a default subnet, and it is occupying all these 256 IP addresses. So let's not do that. So what I will say is no, I want to create multiple subnets as well in this VNet. So obviously, if this VNet occupies all the IP address range, then there is nothing left for my other subnets. So I'll say edit. First, I can give some name. I may say my first subnet, and I will say, please don't utilize all this range, that is 28/24. Instead, utilize /28. It is 16 IP addresses only. And you see, suddenly my subnet IP address range has changed from 10.0.0.0 to 10.0.0.1.5. See, it has become smaller. If I say, okay, use all 28, who is that? Now, sorry, all 20/24. You see, my subnet IP address range becomes larger. But obviously, I don't want this single subnet to utilize all the IP address range. So instead, I will say /28. Correct. And now you see in this subnet, I have only 16 IP addresses. So safer side, let's make it 32 IP addresses. And I can say save. So now in this VNet, I'm creating this subnet. So from 256 IP addresses, this subnet is utilizing only 32 IP addresses. And obviously rest of the IP addresses, they are available for consumption for other subnets. So now here I can say review plus create. And I can say create. Well, again, those who are from developers background, you may be thinking that I'm from a developer background, why I need to understand networking. But trust me, now that's not the scenario. Now I guess yesterday also we discussed this AI work. We should know at least basics of all these concepts, that is networking, then tenants, Active Directory, why Active Directory, and authentication. Yes, all these concepts we should know. So for example, when you are creating a secure app, so for example, let's say from developer, you become architect. So your job is not just to write the code, but you have to make sure your system is secure. And for that, this networking knowledge is okay. Okay, so here I'll say go to resource. So my VNet is created. So again, now we are in this VNet, and first thing, observe this under settings, I have this address space. If I click on it, see, again, we have just 256 IP addresses. Now in this VNet, if I want to find subnets, I can click on subnets. Yes, I have this subnet in this, and it has total 27. You guys remember? We created a subnet for 32 IP addresses, right? So available IPs for us is only 27 because 5 IP addresses Azure has used for its internal management. So I guess Mohan or Sanket, you asked this question.
Yes, understood.
Yeah. And now, see, now observe this range. It says 10.0.0 to 27. That means 10.0.0.0 to 10.0.0.0.31, right? Total we have 32 IP addresses. Now, if I say new subnet, that means we are getting new subnet. And if I say I want to use, let's say, another 32 addresses, see, it has automatically calculated the next available IP addresses. Can you see this? From 32 to 63. I can say, okay, create this subnet too. So again, guys, this knowledge is probably not required if you are just purely working as a developer. But as an way we move ahead, as an architect, you will need to design secure solutions. For this knowledge is must. Now, can you see this range? It becomes from 32 onwards. And again, though we think it should be 32 addresses, but again, Azure has used 5 for its internal management, and we are available only 27 IP addresses. So, any doubt in this now? Actually, I had thought of covering more in these 2 hours, but that's okay. Even if our training gets stretched, I don't mind.
No problem.
Now, any doubts, any confusion? Now I will tell you why we actually need this. So in a real world, what we do is we have a web app posted somewhere. Let's say VM or app service, whatever it can be. Behind this, we always have SQL DB. In front of, we always have application gateway. So the request never reaches to web app or SQL DB directly. We never allow that. We always block such access. From public internet, request always reaches to this application gateway, from application gateway to web app, from web app to SQL DB. And this application gateway, it will be in its own VNet. This web app, let's say if it's hosted in VM, it will be in its own VNet. SQL DB is a pass resource, so it's not a VNet, but then there is something called VNet integration and all that. But see, this is VNet, this is VNet. So ultimately, if you want to create such secure web app, you should have a knowledge of VNet and subnets. Clear?
Yes.
So again, guys, don't worry, we'll see all this practically. That's why we are going slow and steady. These are the basic concepts. So again, let's say this is the application gateway. So again, what is application gateway? Just just forget that. But just imagine that when we have a web app in front of, most probably we'll host or we'll create something called application gateway. It will be in its own VNet and its subnet. So again, this application gateway, it will be available in this subnet. So this is subnet, and here we will create application gateway. Similarly, let's say we have a web app hosted in VM. So this is its own VNet, its own subnet, and in this subnet we will have that VM. And to this web app, again, it's hosted in VM, direct public access. Let's say this is public access. We never allow such access. Never. We allow access only through this application gateway. So only request which reaches to this application gateway, only that is allowed to pass to this web app. So for that, we'll create something called VNet peering. So maybe we'll discuss next week. But just forget that. But I just wanted to tell that, yeah, this knowledge is required. I mean, if you want to just remain developer for years, then probably you don't need it. But yeah, as and when our experience grows, yes, we are expected to know all this. So, guys, any doubt, any queries?
It's clear, Vishal.
Yes, it was a good session.
Yeah. So that's it, guys. Thanks for listening. And again, let's meet next week.